Welcome. Right? So the equation of a circle is x squared minus 4x plus y squared plus 6y equals negative 9. State the coordinates of the center and the radius and the measure of the radius. Now to be able to do that, you need to first put it into standard form. Do not go stating the center and radius. Try guessing at it if it's not in standard form first. And this is what standard form looks like. Right, so standard form is x minus h squared plus y minus k squared equals r squared, where hk is the center and r is the radius. All right, so once we put it into standard form, we can identify the center, right, by making sure it's x minus h and y minus k. And if there's a plus, we know it's minus a negative. And then to find the radius, we just take the square root of the constant that's alone. All right, so let's put this one into standard form. I'm not going to write down I'm going to show every step. I'm just not going to have it in words like the other one. I'll just tell you what step is next. All right, so x squared minus 4x plus y squared plus 6y equals negative 9. All right, so step number 1 would be move the constant term. We don't need to do, maybe I will write it down. Move constant. We don't need to do that because it's already moved. So that is an A. Step number 2 is to put the x terms together and the y terms together. That also is an NA because we've got x squared and 4x and negative 4x together. We have y squared and 6y together. All right, so first two steps aren't needed because it's already been taken care of for us when we were given the equation. Step 3 is to add b divided by 2 squared for the x terms and the y terms to both sides. All right, so we have x squared minus 4x. Right, b is, I'll put it right here, b is negative 4. It's the term that's got the x. And for the y terms, b is 6. So we're going to add to both sides negative 4 divided by 2 squared. Right, and then we need the y squared and the 6y. And we'll add 6 divided by 2 squared to both sides. And of course, I have no space on the other side. I haven't had the whole time, right? So we have the equals negative 9 over there. And we've added a negative 4 divided by 2 squared and a 6 divided by 2 squared, right? So if we do it to one side, I'd do it to the other side. Otherwise, the equation doesn't balance. And you'd have a nonsense number for your radius because your radius can't possibly be negative, right? It's a measurement. All right, so now let's simplify everything. And so that's going to be step 4 is to simplify. Divide by 2 and square and add the numbers together. So we have x squared minus 4x. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. And then y squared plus 6y plus 6 divided by 2 is 3. 3 squared is 9. And on the other side, it was equals a negative 9. And of course, it's a 4 and a 9, right? It's the same numbers. All right, so now we're going to simplify a little bit farther because let's add those negative 9, 4, and 9 together. So we have x squared minus 4x plus 4 plus y squared plus 6y plus 9 equals, well, the 9 and the negative 9 will cancel, and that's just a 4. The next step is to factor. And it's easy to factor, right? It's either going to be x, whatever the sign is, plus or minus, and then b divided by 2 squared, or if you like square root of c, x plus or minus square root of c squared. Either way, it's the same number. All right, doesn't matter which way you do it. So we have x squared minus, excuse me, forgot we're factoring. I don't need to write that down. All right, so I'll put the factoring both ways. All right, so here's the factoring for the x's. All right, so this would be x, and it's minus there, so that's a minus. All right, so right there, minus right there. So x minus, and then b divided by 2. b is negative 4. So the minuses, I'm already taking care of it, right? So it's just 4 divided by 2. And then there's 2 of them, so it's x minus 4 divided by 2 squared. Or if you prefer, you can have x minus the square root of c, right? And so b is the negative 4 and c is the 4. So either have negative 4 divided by 2 or have square root of c, square root of 4, right? And there's 2 of them. Then for the y terms, right, you can either do the b divided by 2, so that would be y. The sign here is plus, so it's y plus 6 divided by 2. There's going to be 2 factors, so it's squared. Or if you don't like to do b divided by 2, you like square root of c, that's fine too. Y plus square root of 9, and there's 2 factors. There's 2 of them when we factor, because this is a perfect square. All right, so either way, this is, oh, and don't forget the other side, which is a 4. Either way, whether you do 4 divided by 2 or square root of 4, it's x minus 2 squared. Whether you do 6 divided by 2 or square root of 9, it's y plus 3 squared equals 4. And now in standard form, we can identify the center and the radius. So the center is 2, negative 3, right? Because this one right here is y minus a negative 3 squared. And then the radius is the square root of 4, which is 2. And that one is done. All right, let's do one more. And then you should be experts at this, right? It's the same set of steps. Really, the only way you get to be good at it is if you do it, right? So you watch me, right? You got to understand the steps, then you do it. All right, so, and I have a note that says this should be in the notes. X squared plus 3x plus y squared plus 7y equals 12. Steps 1 and 2 are already taken care of, right? The constant is isolated. Right, then 12 is all by itself. X terms are together. And the y terms are together. So that's already taken care of. We don't have to worry about that one. So that's a check for those 2. All right, so then we can go on to the next step, which is to add b divided by 2 squared for the x terms and the y terms to both sides. All right, so this gives us x squared plus 3x plus b is 3. So this would be 3 divided by 2 squared. Plus y squared plus 7y plus, right, so for the y terms, b is 7. So that would be 7 divided by 2 squared equals 12 plus 3 divided by 2 squared plus 7 divided by 2 squared. Now notice they're going to be fractions. Do not make them decimals. Keep them fractions. They're much easier to work with, right, especially for completing the square. All right, so now let's square and simplify. All right, so we have x squared plus 3x plus 3 halves squared would be 9/4 plus, well, actually I probably should have switched colors because I'm on my next step, which is simplify. Trying to make it color-coded. That way you can look and see simplify. Ah, that's what I'm doing when the step that's black. And just waiting for, there it comes, a little bit at a time. So x squared plus 3x plus, right, so don't make it 1.5, right, don't make it 2.25 when you square, no, just make it 9/4. Right, and then y squared plus 7y plus square the 7, square the 2, so that's 49/4. equals 12 plus 9/4 plus 49/4. All right, so we're still on the simplifying part. So we have x squared plus 3x plus 9/4 plus y squared plus 7y plus 49/4 equals, now we need to change 12 to be fourths. Right? So 12 is the same, so 12 over 1 is the same as, I'd have to multiply 1 by 4 to get 4. 12 times 4, 48. And if you don't believe me, divide 48 by 4, and lo and behold, you get 12 again. Right? So 12 is the same as 48/4. You need like denominators to add, because you're adding the same size pieces. You can't add different size pieces, right, and call it the same. It's like if you're adding apples and oranges, you add up all the apples and you add up all the oranges. You don't add apples and oranges together, right? So we have 48/4 plus 9/4 plus 49/4. And just add the numerators, because we're adding fourths. That's why you have to have the same denominator. All right, so 48 plus 9 would be 57. And then 57 plus 49 is going to be 106. 106. Which we could reduce, right? That does reduce. All right, so x squared plus, still simplifying, 3x plus 9/4 plus y squared plus 7y plus 49/4. And that 106/4 is the same as, right, so that would be 20, and we have, no, it doesn't divide evenly, but it does reduce. It reduces to, so we could reduce that to 53/2. Well, that's an odd number, no, isn't it? I'm just going to leave it the way it is, I guess, for now. I'm going to make sure I didn't make an error in my addition real quick. I'm going to just double check, double check. Make sure I just didn't forget to carry something or something silly like that. So 48 plus 9, and I wrote all the right numbers down. Yeah, plus 9 plus 49. Yep, 106. Nope, didn't make any mistakes. All right, so let's just leave it like that for now. All right, so no more simplifying. Let's factor now. That's our next step. All right, and one of the reasons I'm not reducing is I notice the denominator is a perfect square. And if I want to find the radius, I'm going to have to take the square root, and I'd rather take the square root of a perfect square. So we're just going to leave it like that and not mess with it until we're done. All right, so now we're going to factor. So now we can do this one of two ways. We can either do x, whatever the sign is, b divided by 2 squared. And of course, it's also the same for the y, right? You can do the x's and the y's the same way. I don't think I remember to write y's, but the same idea. When we're factoring a perfect square, it's going to be an x or a y, depending on which variable it is, and then whatever the sign is of the second term, and it's half that second term. It'll always be that, right? Because that's what will give you that perfect square. It'll give you the last one squared, it'll give you the first one squared, and it will give you the middle term just doubled, right? Or you can do x plus or minus whatever the sign is, square root of c, right? We have seen all the way through this that we get the same answer either way. All right, so now I'll do it both ways, right? So we have x plus, and this is a plus because that's a plus right there, x plus, and then half of 3 is just 3/2. It's the same thing you had right here, right? When you took b divided by 2, and then you squared it. So x plus 3/2, and there's 2 factors. That is squared. This is a perfect square, so that's to be 2 factors. And if you don't like that one, you can also do x plus the square root of c, which is square root of 9/4, and there's 2 of them, so that's squared. And then we'd want to simplify it. What's the square root of 9/4? that would be x plus the square root of 9 is 3, and the square root of 4 is 2. So notice it's the exact same thing. And then plus, got to do the same thing for the y's, right? So we can either take half of b, right? So that would be y plus, because this sign here is a plus, and then half of 7 is 7 divided by 2. The same thing you had right here. And there's 2 of them, so it's squared. And if you don't like it that way, you can take the square root of c, and that would be y plus the square root of 49/4. And so that's a 4. So that would be, and there's 2 of them, so it's squared. So that would be y plus the square root of 49 is 7, and the square root of 4 is 2. So either way, you have x plus 3 halves squared, y plus 7 halves squared, and then don't forget your 106/4. Right, for this part, the last one, we're all done. I'm going to reduce it now, and that was 53 halves. When I go to find the radius, I'm going to go back to the 106/4. Right? So here is the equation in standard form. And now let's find the center and the radius to end this video. Oops. I'm just going to draw the box right through the 4. All right, so, oops. Now this is through the box. There's a nice balance there. All right, so the center. Remember that this would be x minus a negative 3 halves squared plus y minus a negative 7 halves squared, because the minus goes with the equation. So if we see a plus, it's minus a negative, and then equals 53 halves. So the center is negative 3 halves, negative 7 halves, and I'm going to use this, the unreduced one to find the radius. It's the same number, whether I reduce it or I don't reduce it, it's the same number. So the radius is the square root of 106/4. And I can rewrite that as 2 radicals and take the square root of each one. Well, one of them is a perfect square, and that's the 4, so that's 2 in the denominator. So the good reason to use the 4 instead of the 2 is it's now rationalized. All that means is 2 is a rational number. I mean, it doesn't keep on going forever and ever, and square root of 2 is not a rational number, and you prefer not to have radicals in the denominator. Now, 106 we can simplify, probably. All right, so, or can we? No, it's 2 and 53. Never mind. Never mind. 53 is a prime number, 2 is a prime number. So that's just going to be the square root of 106, and we're done. So the radius is a square root of 106 divided by 2. The center is negative 3 halves and negative 7 halves. And this was my challenge problem because you had fractions as your center. You had a radius with a radical in it. But see, the steps are exactly the same no matter what your center looks like or what your radius looks like. The only maybe challenging thing is we had to remember to change 12 to 48/4, and I just knew it was easier to work with 106/4 than it was 53 halves. But even if you worked with 53 halves, you can do that. So notice, so I'm going to show you what happens if we use the radius as 53 halves. So if we use 53 halves, right, we have a radical in the denominator. To get rid of the radical in the denominator, we just multiply. And it's only, if you have a square root in the denominator, you just need one factor, and that's the only kind we're going to see. So to rationalize a square root, you just multiply numerator and denominator by that square root. The square root of 53 times the square root of 2, you can multiply radicals as long as they have the same index. You just multiply what's underneath. So 53 times 2 is 106. Square root of 2 times the square root of 2 is the square root of 4, which is just 2. So either way, you'd still get a square root of 106 divided by 2. All right, so even if you didn't know, hey, it might be easier to keep the 106/4, you could still get this. All right, so that's the end of this, and this is the end of circles. In the next lesson, we'll be looking at parallelograms. All right, things, and bye for now. And now, by the way, you can do the entire homework. All right, so you can do the last 2 pages now. All right, bye for now.